This is another video in the series, Getting Started with Extreme Vigilance from Scianta Analytics. In this video, we're going to use the Machine Learning Toolkit as a way to analyze extreme vigilance signals. Extreme vigilance already comes with a set of views for you to analyze signals, but in this video, we are going to create one to predict anomalies using the ML Toolkit's linear regression algorithm. So let's take a quick look at one of the views already created in Extreme Vigilance using the ML Toolkit. So I'm in the SEM Framework app. Under the Explore menu, there's Explore Signals menu item, and each one of these views has been created using the ML Toolkit for analysis of the signals. We're going to kind of mirror one here. Let's look at clusters of anomalies by extracted source. So this particular one actually groups them by clusters, but what I'm interested in is just showing you the extracted source choice box here. There's like 10 different types of signals that can get generated from analysis, from sequence analysis, threshold analysis, and so forth. We're going to do something similar where you can pick the source. Then also, instead of a time range, we're going to make it pick a day. And we want to be able to predict the anomalies that would be generated on that day. Okay, so this is a great place to get started from. So, to get started, we first have to create a model in the ML Toolkit using linear regression that looks at anomaly signals generated from our analysis. So let's create the command that will do this and test it. Let's create a search to get sequence anomaly signals that are not informational. So all the signals that are generated by Extreme Vigilance are stored in an index, and it's called SEM signal. And we don't want anything that's informational, just want severe reported anomalies. And for testing, we're just going to look at sequence. Extracted source equals sequence. Let's see if we get the signals back correctly. Should be, yep. About 2,800 signals, great. So the next step, let's expand the search, obtain a count from buckets using a span of 1 day. So we're going to go bin underscore time. Span equals 1 day. And this gives that's count by underscore time. Perfect. So this is the information we're going to feed into this model, basically every day, the total count of anomalies by anomaly type. So this looks correct to me with respect to the number of sequence anomalies generated per day. So we can now add the actual ML Toolkit command to the search to use the linear regression algorithm to fit the model to predict the number of anomalies. So the command is fit. The algorithm is linear regression. And we're going to use the same fields provided by the stats command here. So count from time. And we have to give the model a name, and we'll call it predict. So predict anomalies, extracted source type is sequence. And let's just sort the output of this just to make sure it looks nice and we know it works. Great. So now we want to create a saved search that will run this particular search on a periodic basis. And that's what happens with those other views I showed you, that these models that we've created and we're feeding in ML Toolkit, they're running every day, every night, or on some periodic basis. So we're going to clone one of those just to follow the same scheduled interval. Now, let me copy this search. Let's go to the research reports and find the one from the report we looked at as an example, cluster analysis for sequence. We're going to clone this. And let's go ahead and copy in our search. And let's set the names appropriately. Let's predict analysis around anomalies for sequence. So the name is meaningful, description is meaningful, we can go ahead and save it. using their cron scheduled. Perfect. We'll go ahead and save that. Let's create one more. We'll just clone the one we just created. Alphabetical. It's going to be probably in the last page here. There it is. Let's clone one for the sequence type anomalies. Give it the name, predict analysis. It's probably the same naming convention here. Anomalies. This one's for threshold. We replace sequence with threshold. And threshold. Go ahead and save that. Now, important to note is, back on the first page. Let's go back to the last page here. Important to note that when you create these new knowledge objects and searches and so forth, they all tend to come out as private. So we want to change it to be like the others and make them global. Or things are not going to work for us. There's one. Let's do the other one real quick. Good. So now we want to create a macro that our UI will use. As the one that we had looked at had a drop-down box where they could pick the sequence type, or not sequence type, the anomaly type. And we're going to make a macro that will pick the right model based off of the type. They don't know the name of the model. So let's copy the similar macro that was used on that cluster view, XM cluster extracted source. Let's clone him, and we'll just change it with our names. The name will be same, following the same convention. Predict get extracted source. Macro, I'm going to only pass one parameter. So the cluster, we're going to use the name predict. Same over here. As you can see, if you pass in a wildcard, we're going to use a global model. If you pass in a particular sequence type name, if you've been watching the naming convention underscore sequence, you pass in sequence, it'll pull out the right model name. Okay, we go ahead and save that. Let's make sure that my permissions are global. Once again. Okay, we're almost there. The next step is actually to create the report. Let's construct the search. So let's go back to our search. That we want to basically be able to specify a date and get back the predicted anomalies. So I'm going to start out the search empty. And because the parameters are actually going to come from a form, from a token, I'm just going to hard code one for the moment so we can test this. So we'll do an eval prime. We'll pick a format. Here's a pretty common one. Okay, and that's what I'll get from the form. But we want to convert it. It's the time format. %y, %d, %m. Okay. And let's make time. That should do that. Then we want to feed this actually into the command that will apply this to the model. So the ML Toolkit command is apply. And just reference our macro so it gets the right model name based off of the type of signal they're interested in. And we follow this convention. XM predict, and the macro name is get extracted source. Takes one parameter. We're going to test it and just pass it in sequence. Reverse tip. And it's actually, I think we should print out the output to the time and predict. So we put up time. So typed it in right. Great. So for the given date, here's the predicted number of anomalies. All right, we got the report that we want to use here, the search. Let's now create the actual dashboard view. So we're going to go ahead and clone that view that we looked at the very beginning. It was called Cluster Anomalies by Extracted Source. So let's clone him. Let's give the name predict anomalies by extracted source. We're not doing any fancy D3 charts, cluster charts or anything, so we'll get rid of that script reference. We only implemented sequence and threshold, but our ultimate goal was to be able to let them pick any anomaly type as well as the wildcard, which our macro already supports. But for now, I'm just going to do the 2 types in the choice box. And we'll make the default sequence. Okay, we're not going to have a chart. We just took out the script for that. We just want to present the results. So let's get that out of there quick. And then their actual search that we used, we tested, was right over here. Copy. Let's come back over here and replace this search in the table. Now the values are going to come from macros. So time, we're going to actually put a text input field on here, and we're going to give a token name day. And then over here, this token is called extracted source. Let's double check that. Right up here, extracted source is the token. Great. We're going to get rid of this time here, but let's save this for the moment so we can test our results and do a couple more editing to the view. Okay, let's go ahead and open it and edit it that way. It's called extend. It's on the last page. Here it is. Okay. Let's make sure it's global too. Good practice. Okay, now I'll open it. It's not quite working yet. We're going to get there. We're going to get rid of this time range and allow them to pick a day. So let's edit the actual panel. Get rid of the time range. Let's add a text input instead. And we're going to give it a name, day. Make sure they know the format that needs to be there. Yes, I want to search on change, and we want the token to be day. Okay. So far, I think we're getting there. Okay. It's done. Now let's go back and edit our source. Check it all. So we have the extracted source token up here, and we have our day token. So in our command, we're going to take the day token. Oh, it's not percent, it's $1. My bad. You didn't catch me on that. And the macro will take the extracted source. It's $1. And we're no longer using the time chart. Let's get rid of it, release latest. That will confuse things too. Let's save it. Let's give it a day. Let's see how close we are. And it worked. Given the specified day, there's the predicted count. If you want to get a little more creative, we could just make this instead of a table, why don't we make it a single value? Give it a label like predicted anomalies for, how's that? Oh, then we can actually put the token in the title. Let's quickly do that. No mistake, $extracted source. and I'm going to try to have a nice single value. So that concludes our tutorial on using the ML Toolkit here to basically analyze extreme vigilance signals. Now I do encourage you, this is a side note, that we have a wealth of documentation online on our Getting Started pages. There's one that will walk you right through what we just did with the ML Toolkit. So thank you very much.